Hey students, welcome to the final video of chapter 10 and actually this entire school year. So congrats on making it this far. So let's go ahead and get right into it. We're exploring probability still, but what you're going to notice in this video is that we're going to explore two different types of probability. Now, it doesn't really change too much of what we're actually doing with the calculation, but what's going to be interesting is that if we can define or the situation as either independent or dependent, it changes slightly the calculation that we got to do. Okay, so it's still going to be favorable outcomes over the total possible outcomes that we have done in the past. And let me just kind of make sure we refresh that. P of any event is going to be the favorable over total. But we're going to go ahead and see if we can explore a few situations that relate to independent dependent events. So here's how, this is the official, my text getting a little wild here. Here we go. The situations that you're going to encounter are either going to be independent or dependent. Really, independent basically means that if something happens and then something else happens afterwards, the second thing that happens is not affected by the first thing that happens. And I know that sounds really complicated, but we'll talk about that with some examples. So in this definition, you can see the official definition is that it's an independent event if the occurrence of one event does not affect the likelihood that the other event will occur. Okay, so I'm going to go to like flipping the coin example. If I flip a coin twice, the first time it's heads or tails. That's our outcomes. The second time it's going to be heads or tails again. Those are independent events because when I flipped it the first time, it doesn't affect what's going to happen when I flip it the second time. So when we want to actually find the probability of independent events, all we have to do is find the probability of the first time and multiply it by the probability of the second event. So we just keep multiplying. So if we have 3 events, we just keep multiplying each event and we figure out the individual properties or probabilities. So it's very straightforward. It's something that we've done in the past with calculating probabilities. We just got to multiply multiple versions. Then it gets a little bit quirky when we start looking at what's called dependent events. Okay? Events are dependent if one event does affect the likelihood of the other event. Okay? There's some in these type of situations, what you got to be careful of is that when we calculate the second event, okay, our total possible outcomes is going to probably change. Okay, so it's going to make a little more sense when we look at some examples. But the official definition or way that we calculate probability dependent events is that the probability of A and B both occurring is the probability of A, the first event, times the probability of B, the second event, but after A just basically means that the total outcomes have changed. So let's go ahead and try a couple of these, right? It's a lot easier to see when we actually look at some core examples. Independent events are the most straightforward, so I'm going to kind of fly through these real quick. It says, you spin the spinner and flip the coin. What is the probability of spinning a prime number and flipping tails? So PA, I'm going to define my events, make it a little more formal, is going to be prime number. And if I look here, there are 1, 2, 3, 4, 5. Prime is going to be 2, 3, and 5. So the probability of A occurring for a prime number is going to be 3 out of 5, okay? Because it's only divisible by 1 in itself. Now, as we are looking at the probability of event B, flipping a coin, okay, and getting tails, the flipping a coin does not change its probability based on spinning the prime numbers. So these are independent events because they don't interact with each other. So the probability of B, and that's a tail, is going to be 1 out of 2. So probability of A and B both occurring, okay, is going to be 3/5. That's the prime probability times 1/2. Finishing that off, it becomes 3/10. So the probability of flipping or spinning a prime number and then flipping tails is 3 out of 10. Okay, and you notice the key calculation is right here. The beginning stuff right here is just for my personal notes, but if you can do the second portion, you should be okay. So, and just for labeling, that's event A and that's event B. Okay, so nothing really changes in calculating the probability of independent events from what we've done in the past. Now that we're doing multiple events, we got to multiply it. So another quick example, what is the probability of spinning a composite number and flipping the tails? So a composite number is 4, so P of A is 1 out of 4. Composite means 1 out of 5. Composite means that it's divisible by a different number other than 1 in itself. And probability of B, which is the tails, is 1/2. So the probability of A and B is going to be 1/5 times 1/2. So the overall probability is 1/10. So you got a 1 out of 10. Oop, let me go ahead and zoom out so you can actually see the whole thing. You got 1 out of 10 probability of getting a composite number and flipping a coin. Okay, not very good odds overall, or not very good probability. It's very low. All right, so that's independent probability. Okay, so with multiple events, you just keep multiplying them through to get the overall probability. Dependent changes a few things. Okay, it's still the same setup, but we got to be careful about what our total outcomes are. So this is a good situation here. People are randomly chosen to be game show contestants from an audience of 100 people. You are with 5 of your relatives and 6 other friends. What is probability that one of your relatives is chosen first? That's definitely event A. Okay, and then one of your friends is chosen second. That's event B. So when I look at something like this, the probability of A, okay, is going to be, all right, that one of your relatives is chosen first. So the first choice, you got 5 out of 100 because you have 5 relatives and then 100 people total in the audience. After that, okay, this is a dependent event because once your relative is chosen, the number of people available changes. Okay, so instead of 100 people in the audience, now you have 99. You have 99 people in the audience. Okay, so if one of your relatives is chosen first, okay, then the number afterwards ends up, total possible outcomes ends up changing because it drops by 1. One of your relatives is chosen, now there's 99 people left. So in the second probability, it's dependent, and one of your friends being chosen, it's going to be 6, not out of 100, but it's going to be out of 99 because now we only have 99 people left in the audience. So the overall probability, P of A and B, is going to equal 5 out of 100 times 6 out of 99. And let's see what that comes out to be. All right, I'm taking out my handy dandy calculator, and let's go ahead and punch this out. I could go ahead and simplify those fractions before I put it in, but because we're so used to using a calculator for many of this stuff, I should go ahead and do it appropriately. Okay, so 5 out of 100 times 6 over 99 is 1 out of 330. So what we're looking at in this situation is that the probability of having one of your relatives chosen first and then one of your friends chosen second is 1 out of 330. And because there's only 11 of you total out of 100, you can see that this probability does make sense. It's going to be very rare that something like this happens. But the key thing from this problem to get is that because they're dependent, the first choice, you have your full pool of 100 to choose from. That's the total possible outcomes. But after the first choice is making, it drops down to 99 because we have eliminated one choice, and that changes the probability of the second event. So let's try one more just to drive this home. In example 2, what is the probability that one of your friends is chosen first, then you are chosen second? So the probability of A, event A and B. So I'm just going to kind of quickly do this shorthand. So if one of your friends is chosen first, it's 6 out of 100, and then it's 1 out of 99 because you being chosen second is basically just one possibility out of the 99 that's remaining. Okay, so finishing that off, we have, and this is definitely going to be a less, the probability of something like this happening is much less than the previous one, and you can see that it's a 1 out of 1,650. So that would be a very rare chance out of an audience of 100 that something like that would happen. All right, so one more to drive this home. This is one of those classic not statement ones that been pretty popular the last few days or last few lessons. What is the probability that you, your relatives, and your friends are not chosen to be either of the first two contestants? So this one is kind of interesting because if we got to think about this a little carefully. If they're not being chosen, so there are 100 total in the audience, and you are with 5 relatives, 6 other friends, so there's 12 of you total. If you consider 5 plus 6 is 11, then you yourself is 12. So that means if you are not chosen first, there is a probability it's 100 minus 12. That's 88 out of 100. And then after that, okay, if we're looking at this situation, it drops down to 99, okay, and there's 99 possibilities, and there is 87 left over here. So just to kind of break this down again, if you're not chosen, there's 88 possibilities out of 100 in the audience for the first choice. But once someone is chosen, it drops down to 99 left in the audience, and there's only 87 possibilities left because we got to subtract that from the 88 that's already that was available in the first one. So that's why these are dependent style events. Going ahead and putting in the calculator, it comes out to be 58 out of 75, which, all right, I don't need to convert that to a percent, but you can see because of the fact that there's 12 of you out of 100, which is a low number, it is a higher probability that you're not chosen along with your friends and relatives. Okay, so hopefully this went ahead and gave you a good look at independent dependent events. All right, review the notes as needed, but let me go ahead and roll out a couple of OYO problems right here. Okay, let me zoom out so you can see it. I'm going to roll the video for about 10 seconds, pause as you need it, and then the answer key will magically show up in just a little bit. Okay, go ahead and give these 4 problems a try. All right, students, you see the answer key pop up. Just to give you a little insight into both, 1 and 2 were independent events because flipping the coin after you spin, the spinner is not going to change the possible outcomes, okay? And then, okay, 3 and 4 were dependent events, okay, dependent. And what you should notice for the dependent, they're a little bit trickier, but you got to think, okay? They're dependent because you didn't replace the first chip, so the total possible outcomes changed. So if choosing an even number, okay, you had 3 out of 6, okay, that's for, I'm looking at question number 3. Choosing an even number, you had 3 out of 6 was the probability. And then choosing an odd number after that, there are only 5 chips left, and there's only 3 odd left. So it'd be 3 over 5. So multiply those together. For the second one, it says choosing a number less than 3. Well, there's 2, 1 and 2, so there's 2 out of 6 possibilities. And then choosing a number greater than 3, well, okay, someone might have noticed I made a mistake here, and I'll make that note here. Yeah, that was a horrible mistake. And that is the most common mistake, not changing the total possible outcomes. It should be 5 because there's 5 chips left, but there are 3 numbers greater than 3 in this case. So with that being said, it would be 6 out of 30, okay, which is going to reduce, let's do that real quick. All right, 2 out of 10, which is 1 out of 5. Okay, 1 out of 5. So don't make that mistake I just made, but the key thing is that for dependent, you're going to notice that the denominator actually changes. The total possible number of outcomes ends up lowering because you're not replacing something or something happened in the previous event that changes that. Okay. All right, with that being said, students, review the video as needed. Always look back at some of the other examples in the textbook. Dependent and independent can definitely be a little bit trickier, especially dependent, so you got to think your way through some of those, but look at some of the other examples if you need it, okay? Reach out to me with questions, all right? Feel free to work on the Big Ideas Math Online work as soon as you got it, okay? It should be available now. All right, thanks. Have a good day.